Okay, so 4.2, one-to-one functions and inverse functions. So a function is one-to-one if basically each pair, xy, is unique, okay? So two different outputs correspond with two different inputs. So an example of a one-to-one function would be A. So 1, 4, 2, 6, 3, 5. Each pair is unique. Each ordered pair is unique. Okay. And then these two, I know it's kind of messy, these two are not one-to-one because these both go to the 5 and these both come from the 2. But one of them isn't a function at all. So which one is not a function at all? Think about what a function looks like. So if you were to graph this versus if you were to graph this, which one would fail the vertical line test? Well, if you have a 1, 5 and a 2, 5, that's okay. But if you have a 2, 4 and a 2, 5, that one would fail the vertical line test. So this one is not one-to-one. This one is also not one-to-one, but it's also not a function because a one-to-one function has to be a function, firstly. Okay. And then basically, so we just talked about the vertical line test. To tell us something's a function, there's a vertical line test. But to determine if it's one-to-one, after you use the vertical line test, you can use the horizontal line test. So if you were going to do a quick graph of these two functions, and you should be able to do a quick graph of those two functions, then you can see, oh, a vertical line test here, yeah, that's a function, and yes, this is also a function. But the horizontal line test, if you go through here, oh, that's okay, you only pass it once. If you go through here, see, you had to pass it once, twice. So that's no good, that's not one-to-one. So that's why this one is not one-to-one, this one is one-to-one. Okay, so if you graph it, it's very easy to see visually. And if you have points, it's pretty easy to tell as well. Okay, the next part is talking about inverses. So an inverse is when you switch the domain and the range, so the x and the y, the input and the output, right? Those are, you just switch them and then you solve for the new y, basically. That's your inverse, okay? That's your inverse. How do you verify? So when I say verify, you're checking, you're proving, you're showing. So all of those words mean the same thing. You are going to show, you are going to prove inverse functions by doing two things. You want to do specifically both of these two things. You have to show that its composite function is x, and then if you do it the other way around, do the other composite function, you still get x. So you have to do both! Exclamation point. Both. Both. You're like, Ms. Tan, stop. Okay, both. So what I'm going to do is if you have an f and a g and you are asked to verify that they're inverses, there's no question that they're inverses. You're not finding the inverse, you're verifying. You're going to plug one into the other and then do it again the other way around. So I did the first one with you. So f of g of x equals, and then you plug all of, I'll use parentheses here. You plug all of g into here. So then you have this basically parentheses. And then what can you do first here? The one thing that you can do is you can add and subtract the ones, and then you get it to this step right here. And then you can multiply by the reciprocal because you're dividing by a fraction, or you can multiply by LCD over LCD, and no matter what, you get x at the end. So your second to last step looks like this. That's your second to last step, okay? And then if you go the other way around, so I actually asked you guys to do this on your notes to guarantee that you do it twice. So then you're doing g of f of x, and then we did that together. So I don't think it's here. Yeah, I don't think it's here. I'll write it out with you guys, okay? So that's when we plug f into g. So 1 over all of that, 1 over x minus 1, and then plus 1. So 1 over something plus 1, 1 over something plus 1. All right, the only thing you can do here is clear that complex fraction. So multiply by the reciprocal, and you get x minus 1 and then plus 1. Oh, minus 1 plus 1, that gives me x at the end. Yay! This is what you will always have at the end if you're verifying or showing or proving. Look at the step above. See how these are different? They are not going to be the same about 95% of the time. They will usually be different the step above. When I check your work, I glance at your work. I'm being honest. I glance at your work and then I look for this step and I already know what they should be. Okay? So that's the step that I usually check. And then if these are the same, then I check a step above and I know what those should be. And that's how I check your work. If you just do this and you're like, that equals X, you will not get anywhere close to full credit, all right? You'll get some credit because you're like, you understand what you're trying to do, but you do have to show work, okay? To show me like, how do you get there? What are the steps? All right, so finding inverses, I did the first one with you super duper quick because you guys already know how to do it. So how do you find an inverse? You switch the x and the y's, and then you solve for y, right? So minus 3, and then divide by 2. All right, so there's your inverse of the original. Okay, this one we took a little bit more time with. So this one, you're gonna switch the x and the y's. So that's my first step. I always draw this to show myself that I'm doing that switch. I'm gonna make this a little darker. There we go. So I switch my x and my y's. And then we said the next step was, okay, let's go ahead and clear that fraction. Let's multiply both sides by x plus, or sorry, that's an x minus 1. Jeez. Let me fix that. Otherwise, you know, it's wrong. So minus 1. Okay, so multiply both sides by x minus 1. And then that means we get this. And then you're going to distribute the x because we want everything like on an even playing field. You know what I'm saying? So now, no more fractions, no more parentheses. Okay, so we're here. So our end result is to get the y's to equal something, right? So just y equals, that's our end result, y equals. So that means I probably want my y's on one side, everything else on the other side. So to get my y's on one side, all right, let me subtract this to the left side and let me add this to the right side because I want all my y's here and I want everything else on the right side. All right. So then factor out the y, and then you get this, and then you can solve for y by dividing, right? And then you're just going to state like, oh, but x does not equal 2 because that's not part of the domain, okay? All right, so in the next step, it says find the domain and range of the function. So some of the classes went through this and some of us didn't, but we're going to use that same function as before, okay? So you're going to rewrite that. You're going to find the domain and the range. Well, the domain is easy. The domain, I just look on the bottom. Okay, so the domain is easy. I put a check mark, but really that should be boxed. Okay, so that's the domain. We're all good. To find the range, you can do one of two things. And here's one thing that you can do. I usually don't list the second one, so it's not on here, but I'll say it out loud. So to find the range, what you can do, and some people did type this into the chat, is you can find the inverse and then take the domain of that, right? Because domain and range of inverses switch. So first, find the inverse, which we actually already did up here. And then the domain of the inverse is the range of the original. See how happy I am about that? So this is one way that you can do it. We'll talk about the other way in a second. And then let's see, so the domain of the inverse, here's the inverse, the domain of that would be the range of the original. So that means that my range is from negative infinity to 2, skip over the 2, all the way to infinity. Okay, how else can you do this? This is one option. Another option that somebody else thought of was, well, if we were going to graph it, so imagine, you know, an XY, your range goes from bottom to top, and wouldn't it have to skip over a horizontal asymptote? Doesn't that have a horizontal asymptote? So you can also just find your horizontal asymptote. How do you do that? Well, it depends. So if you remember how to find a horizontal asymptote. For this one, it's going to be 2x over x, which is just 2, because you have the x to the first and x to the first. So y equals 2 is your horizontal asymptote. Oh, look, we're skipping over the 2. So there are multiple ways to get a horizontal asymptote. You can find to get a range of a function. You can do the horizontal asymptote, or you can find the inverse and then use the domain. Okay, you should know how to do both, but you have 2 ways to do it. Okay, so the last part is graph the inverse. So to graph the inverse, there's also multiple ways that you can do that. So we want to graph the inverse of x squared plus 1. Okay, you have 2 options. Do whatever you think is easier. Option 1, find the inverse and then graph it. Right, so how would you find the inverse and then graph it? I'm going to do it right here. So switch the x and the y's. X equals y squared plus 1. Okay, y squared equals x minus 1. And then y equals, do not forget what comes first, plus or minus x minus 1. How many people are going to forget that plus or minus? So freaking many. Do you really want to graph this? You can. It's not actually hard to graph. Let me remind you. So what does square root of x look like? Square root of x looks like this, right? It goes 1, 1, 4, 2. So what does it mean when it's x plus 1? It means we go to the right one. So it starts here, and then 1, 1. Let's do that. And then 1, 2, 3, 4, 2. Okay, so this is the positive square root of x minus 1. What about the negative square root? It would be down here, negative square root of x minus 1. Okay, so you can do it that way. I'm going to save this here. It says whatever's easier. Okay, that's one option. The other option is to graph the original and then flip it over the line y equals x. How come we flip it over the line y equals x? What is y equals x? Well, it's the line where you have like a perfect diagonal, right? So it would look something like this. What does the original function look like? Can you graph that easily? Yeah, you can. You better be able to. This is a perfect parabola that goes through 0, 1, so it goes something like this. So if you graph the blue one, you can use the blue one and flip it over. I like to do this. I like to make that diagonal coming like up and down. I like to make it vertical for me, okay? So if you put that diagonal, then you can see everything on the left side and the right side are the same. So this point right here, this point right here, this point right here was 1, 2. What's the inverse? 2, 1. This point right here was 2, 5. What's the inverse? 5, 2. So you can graph the pink one by doing the blue one first and then reflecting, or you can find the inverse and then graph it, and you don't have to do reflections, okay? It's up to you, but you do need to know how to do both. Okay, so usually in class, we choose one and we say, what's easier? So when you look at this, you're like, I don't want to graph that. So usually people find this to be way easier. So when you graph it, you get those points, right? So you move it up 1, you graph it really nicely, and then you choose some points, and then you go, okay, this is, you know, what we said, it was 1, 2, this is negative 1, 2, this is 2, 5. So after you graph it, you use a few points, and then you draw that line, y equals x. So see that dotted line, y equals x? And then after you draw that line, y equals x, you use the reflection over that line to draw your inverse. And then what you can also do is you can use some of these points. Instead of 2, 5, you should have 5, 2. Instead of negative 1, 2, you should have 2, where is it? 2, negative 1, which is actually down here. So you have this point, instead of 0, 1, you have 1, 0. and then you can go ahead and graph that right side. So you should actually, at the end, label that this is y and this is y prime. I'm gonna go like this because I can't handle that. Okay, so this is y prime, this is y, so that, you know, if you have two graphs, you need to know what's the answer. So the answer is y prime, that one's the inverse, okay? So you can graph it that way, or like I said, you can solve and then you can graph it. So either way will work. It's up to you, but you have to be real neat no matter what you're doing, and don't forget about the plus and minus, because this is positive root, this is negative root. So do not forget about that. Okay. So there are your notes, and your homework is posted. If you want to start on it, you don't have to. It's up to you.